Essential math skills in A-level biology with DrBiology.
Hi everybody, it is DrBiology here, and this video is on units and prefixes. So, okay, units. Well, why do we use units? Well, we need to have an international system of units to make the conversion of units mathematically simple, and also so everybody understands what those units are and what do they mean when you're measuring and observing things in biology. So sometimes though you might need to change between units, so knowing how to do a conversion is a very useful skill. So there are different rules, and I'm going to go through those rules right now. So first of all, here we go. So common units. Now this is actually an AQA. This is from AQA, and it just shows, there's a lot of information here. I'm not going to go all the way through it, but it does show all the factors and exponential numbers. Now I would say what's more important is probably the bottom half of the of this table. In terms of biology, we're particularly interested in things that are very small, so we're looking at things like micrometers and possibly nanometers. We're not looking at atom molecular structure, okay, picometers, but you know, around from meters down to nanometers is going to be the most important, okay, and also masses, grams down to probably micrograms, milliliters, microliters, and then milliseconds and microseconds. So first rule, to convert from a bigger unit to a smaller unit, you need to multiply by the conversion factor. So here we have from meters to centimeters. Okay, so what we've got here is the centimeters are smaller than the meters, so this needs to be a multiplication. So 3 meters times 100, because 1 meter equals 100 centimeters, so the conversion factor is 100, so that would be 300 centimeters. It's important to know what the conversion factors are. Okay, rule 2, to convert from a smaller unit to a bigger unit, you need to divide by the conversion factor. So from grams to kilograms, so grams is smaller, kilograms is well, it's heavier. So you've got 4,000 grams, so kilograms are bigger than grams, so this needs to be divided. So it's divided by the conversion factor, in this case is 1,000, okay, because there's 1,000 grams in 1 kilogram, so that would be 4,000 divided by 1,000, which gives us 4 kilograms. Rule 3, there is another rule. If the area units are squared, you should square the conversion factor as well. So for example, meters squared to centimeters squared, well, it's the units are square meters, so 4 meters squared, so you times it by the conversion factor. So conversion factor from meters to centimeters is 100, so the conversion factor for meters squared is centimeters squared, which is 100 squared. Okay, so you're squaring that conversion factor, which is 10,000, so that would be 50,000 centimeters squared. And then conversely, if the volume units are cubed, you should cube the conversion factor. So we've got decameters cubed to centimeters cubed, so the units are cubic decimeters, okay, and then 1 decimeter or decameter equals 10 centimeters, so the conversion factor from dm cubed to centimeters cubed is 10 cubed, so it's 10 times 10 times 10, so that's 1,000, so that gives us 8 times 1,000. It's quite a lot to take in there. Right, okay, so here I have for you, I've got some questions. Okay, so as always with DrBiology, I like you to pause, and I would like you to have a go at those questions, please. Okay, so in 3, 2, 1, and pause. Okay, so let's see how you got on. So 42 kilograms to grams, so that's 42 times the conversion factor, which is 1,000, so it'll give you 42,000 grams. 5 meters cubed to cubic centimeters, well, 5 meters cubed times the conversion factor cubed, so it's 100 cubed, so that would be 5 million centimeters cubed. And then 2000 centimeters squared to square meters, well, you would divide it because centimeters to meters is from small to large, and because it's square, it's 100 squared, so it's 0.2 meters squared. Next one, the body of a locust is 7.1 centimeters long and its mass is 1.8 grams. What is its length in meters? Well, that's quite simple. It's 7.1 divided by 100. Again, you're going from small to large, so you divide. What is the mass in milligrams? Well, milligrams, you've got grams, 2 milligrams, so it's multiplication, so it's 1800 milligrams. Next one, so the adult's human kidneys process approximately 1,200 centimeters cubes of blood every minute, which is quite phenomenal. So what is the volume in cubic decimeters? Right, well, centimeters and decimeters. So basically decimeters in centimeters into decimeters, you can divide it, so it will give you 1.2 dm cubed. How much blood is processed by the kidneys every second? It's a bit harder, that one, at millimeters cubed, so you got to convert it to centimeters to millimeters and then work out every second. Well, there's 60 seconds in a minute, so what you would do is take the 1200 divided by 60 to get the answer, 20 centimeters cubed, but then convert it into millimeters cubed by timesing it by 1000. Okay. Sometimes you will get exam questions like this one. Okay, so let's just work through this one together. So it shows some features of gas exchange of a fish at rest. So it gives you the volume of oxygen absorbed in dm cubed per centimeters cubed, dm cubed of water per centimeters cubed, mass of fish in kilograms, and oxygen required by fish per centimeters cubed per kilogram per hour. And it says calculate the volume of water that would have to pass over the gills each hour to supply the oxygen required by the fish. Okay, so let's think about that. So the volume of water that would pass over the gills each hour to supply the oxygen required by the fish. So I'm going to go through this one with you. So first of all, what I would do is you need to work out how much oxygen is needed for a 0.4 kilogram fish. Okay, so you look at the oxygen per kilogram, so it means basically that means 90 centimeters cubed of oxygen is required per kilogram per hour. So therefore 90 centimeters cubed times 0.4, so that's 36 centimeters cubed per hour of oxygen is required. However, okay, that's if the fish, well, that's per hour, so we need to know about dm cubed. So if we look at the volume of oxygen absorbed by the gills, so it means 7 centimeters cubed of oxygen is absorbed per dm cubed of water passing over the gills. So what you would do is divide it, okay, because you want centimeters into decameters, so you take the 36, divide by 7, and that gives you the answer of 5.1 dm cubed per hour. And there we go. Okay, so it's whistle stop tour of units and prefixes. Key thing is to remember the rules when you get smaller and larger, or larger and smaller units, whether you multiply or divide. And also it might be worthwhile learning some of those units as well. Okay, so what are the conversion factors for different types of unit, particularly in biology, the smaller units. I hope you found that useful. Please do subscribe, put your alert reminder on, because there'll be more math skills in biology videos coming shortly.